we're in Honors Algebra 2 Pre-Calc, section 6.4 of Pre-Calc. This is a proof of the angle between two vectors formula, which is that cosine theta equals u dot v over the magnitude of u times magnitude of v. Thing about this video is that it's totally optional. You don't have to know how to prove this stuff. You just have to know the formula, but it's sometimes fun to figure out where these formulae came from. In this case, it's going to use the law of cosines. So this proof is going to use the law of cosines and a little bit of, which was in 6.2 by the way, and a little bit of like fun vector trickery. So I'm going to scooch over and give myself some space, and we're going to talk about how to prove this formula in a minute. So first thing I'm going to do is I'm going to draw a situation that we could be looking at here, right? So I have some vector v, right? So that's my vector v, which means that this side length is going to be the magnitude of v, right? Because that's how long it is, right? And I have some other vector that I'm going to call u, right? And that makes this side length of the triangle the magnitude of vector u, okay? So this angle between them is what I'm calling theta, and that's the thing I'm trying to find, right? But in order to do this, the problem is I need something else, right? And this is what makes this problem a little tricky. So this missing side, right? What I want to point out to you is that if I use head to tail, right? If I add from head to tail, if I take vector u, right? So if I do vector u plus this mystery vector that I don't know, it should give me vector v, right? Because vector u and then plus whatever this vector is should have a resultant vector of vector v. Well, that means that my mystery vector is vector v minus vector u. And you can see that because I could solve by subtracting that over. So this mystery vector is actually vector v minus vector u, meaning that the magnitude of this is the magnitude of v minus vector v minus u, right? The whole vector v minus u. So let's walk through this now using some law of cosines. All right, so in law of cosines, we're used to seeing triangles where we label like an A, and so then this side would be little a, right? And if I call this side B, then this side would be my little b, right? And if I call this this C, then this would be my little c. So let's make a list of the stuff we know. We know big angle A is theta, right? So we know big angle A is theta. And actually, let me buy myself a little more space here because we're going to need it, right? I don't know big angle B. I don't know big angle C, right? Those are big unknowns. I do know little a. Little a is apparently the magnitude of v minus u, which we're going to deal with in a sec. I do know little b. Little b is apparently the magnitude of u, right? And I do know little c. It is the magnitude of v, right? So this is a perfect setup for the law of cosines, right? The law of cosines says that you can either solve it for cosine or you can solve it for the a squared, but a squared equals b squared plus c squared minus 2bc cosine of a, right? Which if I solve for the cosine, because I know that's where I'm headed, I want to solve for the cosine, I get that this is a squared minus b squared minus c squared all over a negative 2bc. That should give me my cosine a. And you could cancel a negative if you want, that's fine. So what ends up happening is I can plug these values in and clean them up to make them look like this, right? So up to you where you start, right? But so I would suggest that a logical place to start is to deal with this annoying magnitude of u minus v, right? So this is what I'm going to be doing. I'm going to argue that if I clean these guys up and plug them in here, they're going to cancel and give me that original formula that I have. So let's start by talking about the sort of annoying thing in the room, which is what are we going to do about this magnitude of vector v minus u? So remember that if I do vector v minus u, right? That whole vector v minus u, dot itself, right? If I do that times itself, then what I'm going to get is vector v minus u, its magnitude quantity squared, right? That's one of the properties of a dot product. Sorry, didn't move over far enough. So I'm going to argue that I could rewrite this, right? Based on the rules that we've seen about the way dot products work, right? I'm going to argue I can clean this up, and I could make this vector. So I'm going to go ahead and essentially FOIL out my dot product, for lack of a better way to do it, to use my dot product properties. I'm going to argue that this is vector v dot product itself, right, first. Outer would be minus a v dot u. Inner would be minus a u dot v. We'll talk about that in a sec. And the last would be a plus u dot u, right? I'm going to argue that this is the same as this other statement, right? which for the record, again, was my a squared. If we look at what my a was, a squared. So this thing is going to get to be replaced by all this crazy stuff. So I know that that v dot v should be the magnitude of v quantity squared, based on the definition of that. And I see that there's 2 of this dot product of u dot v, because remember, dot products are commutative, so u dot v is v dot u, plus what seems to be a magnitude of u squared, right? So that's what all this stuff is. So I'm going to argue that all of this can sit in place of my a squared. So now let's take a second. Again, if you're like, oh my gosh, Hogan, I'm done, why would you do this to me? Then you can stop watching this video. It's totally okay. I'm just showing you how it would work. So if I plug in all these values that I have now, right? So I'm going to come over here now. I'm going to plug in everything that I had in blue here for my a squared. So my a squared was the magnitude of v squared minus a 2 u dot v plus the magnitude of u squared. Okay, so now I'm going to go ahead and plug in what my b squared is. Well, my b was a magnitude of u, so my b squared minus b squared should be minus the magnitude of u quantity squared. Okay, my c squared was the magnitude of v, so this should be minus the magnitude of v quantity squared, right? And on the bottom, I should have a negative 2 times the magnitude of u times the magnitude of v. Right? And apparently that's supposed to be my cosine theta. Now, it looks awful, but this is going to clean up really fast to exactly what I want it to look like. I want you to notice that right now I have a positive magnitude of v squared. I have a negative magnitude of v squared. Well, they're going to sum to 0. The same thing happens to this magnitude of u squared and this negative magnitude of u squared. So what ends up happening, if I inch this up here a little bit, is I end up getting this as negative 2 times the dot product of u and v over a negative 2 times the magnitude of u times the magnitude of v. That's going to be a cosine of theta. Well, look what happens to the negative 2 coefficient, and sure enough, there's the formula that I started with, u dot v over the magnitude of u times the magnitude of v. That's my cosine theta. So that's where the formula comes from. Again, if you're like, whoa, Hogan, I did not need to know that, then that's cool. Just erase it from your brain. It's all good.